Hi everyone, welcome back. We are moving on to Module 3, Topic 1, Lesson 3, Activity 3 on page 381. Habits of mind, look for and make use of structure, look for and express regularity in repeated reasoning. Factoring algebraic expressions. It says you have used the distributive property to multiply and divide algebraic expressions by a given value. You can also use the distributive property to rewrite an algebraic expression as a product of two factors, those being a constant and a sum of terms. So a product of two factors, one is a constant, the other one is a sum of two terms. Let me move this. Okay, so then it says, you can write any expression as a product of two factors. In many types of math problems, you often need the coefficient of a variable to be 1. It says, let's explore how to use the distributive property without algebra tiles to rewrite expressions so that the coefficient of the variable is 1. So number 1 says, consider the expression 3x plus 6. Identify the coefficient of the variable term. Well, so the coefficient is the number associated with the variable, so the coefficient is 3. Then it says use the distributive property to rewrite the expression as a product of two factors, the coefficient and a sum of terms. So the coefficient is 3, and it's the product of two factors, so this factor and says the coefficient and sum of the terms. So 3x plus 6, if I use the coefficient as one of the factors, what would I have left remaining? I would have an x plus 2. So if I factor out a 3, 3 divided by 3 gives me the x, 6 divided by 3 gives me the 2. How can you check your work? You can check your work by multiplying, by distributing. So by distributing the 3. So we would have 3 times x plus 2. And when we're distributing that, we do 3 times x, which gives us 3x. And then 3 times 2, which gives us 6. Which is what we started with. In the expression 3x plus 6, you factored out the common factor of 3 from each term and rewrote the expression as 3 times the quantity of x plus 2. In other words, you divided 3 from each term and wrote the expression as the product of 3 and the sum of the remaining factors, x plus 2. Take note, when you use the distributive property to rewrite the sum of two terms as the product of two factors, you're factoring expressions. So basically, if we just pull out the common factor out of 3x and 6, we pull out the common factor of 3, then we are factoring expressions. Using the distributive property to write an expression as a product of two factors is also known as factoring. Okay, 382. You can use the same strategy to rewrite an algebraic expression so that the coefficient of the variable is 1 even when the terms do not have common factors. So in this case here, the 3 was a common factor in both 3 and 6. What they're telling us now is that we're not going to have a common factor. So I think the way that they've explained it here is there's kind of a lot on the page, and I think it's going to be a lot for your brain to kind of process, so I think I can make it a little bit easier. So it says, remember, you can multiply or divide any expression by 1 and not change its value. Okay, so we'll try to go through this. Let's rewrite the expression 4x minus 7 so the coefficient of the variable is 1. To rewrite the expression, factor out the coefficient 4 from each term. Well, so they have 4x minus 7, and so they're trying to divide a 4 by each of those, pulling that factor of 4 out. I really don't like how they're doing that here. It almost looks like it has an extra number here. It says the equivalent expression is the product of the coefficients and the difference of the remaining factors. So let me just kind of do this a little bit differently, and it's not necessarily what they want right here, but this is what we're going to write here. So 4x minus 7. So they're saying they want this 4 to not be here. They want the number in front of the x to be a 1. They want its coefficient to be a 1. So how do I get it to be a 1? Well, I need to divide by 4, because 4 divided by 4 gives me 1x. So there is as the 1, and you know we don't need to write the 1. But if I divide this part of the expression by 4, in order to make the entire expression still equivalent, I would also have to divide this by 4. So if I'm dividing by 4, that's the factor I'm pulling out. And then here I'm left with 7/4. So 4 times the quantity, x minus 7/4. Now to check it, we'll multiply. So 4 times x is 4x. And then we have 4 times 7/4. I'm going to put the minus sign. Then I have 4 times 7/4. That 4 is over a 1. Your 4's cancel out. They're 1s. 1 times 7 is 7. 1 times 1 is 1. So we end up with 4x minus 7, which is in fact what we started with. Okay, so number 3, it says rewrite each expression as the product of two factors. So again, we want the x to be a value of 1. So we're going to factor out the 4. So when we're factoring out the 4, that means we need to divide both of these. I'm going to move this down. We need to divide both of these by 4. Why does my pencil always run out of lead? Time to pause. Okay, have a new pencil. Okay, so if I want this 4 to be a 1. So if I divide it by 4, 4 divided by 4 gives me 1. And I'll be dividing this by 4. Okay, so what I'm really doing when I do that is I'm factoring out the 4 and pulling that 4 out to the front. Kind of undistributing it, as you might say. So 4 times x would put me back to the 4x. Plus 5/4. Check it with distributing it. 4 times x is 4x. 4 times 5/4. So 4 over 1 times 5/4. 4 divided by 4 is 1. 4 divided by 4 is 1. 1 times 5 is 5. So we get 4x plus 5. So that is what we started with. So this is the correct answer. Okay, let's look at letter B. So we want the x to have a exponent of 1. So if we factor out an 8, right, because we would have to divide by 8, divide by 8. Okay, so when we pull that factor of 8 out, now if we try to distribute it to check our work, 8 times x is 8x minus 8 times 3. So it's 8 over 1 times 3/8. And you can either look at it as the 8's canceling out, and you end up with 8x minus 3. Or if you multiplied straight across here, you would get 24 over 8, which we know equals 3. So we would come back to that. Okay. Trying to decide if I want to do C and D. All right, we're going to give it a shot. Not sure how you're going to do with this. We're going to do the same thing that we did here. We're going to divide each of them by the coefficient. Okay, so we're going to factor out the 1/2. That would leave us with the x here. 1/2 divided by 1/2 is 1. Minus, then we have a 4 divided by 1/2. So it's really 4 over 1 divided by 1/2. And remember, we're not going to divide a fraction. We're going to multiply by the reciprocal, or keep, change, flip. Now we have 4 times 2 is 8. 1 times 1 is 1. So this becomes 8. Check it with the distribution. 1/2 times x is 1/2 x. 1/2 times 8, or half of 8. Half of 8 is 4. Takes us back to our original. Same thing happens here. Divide by 0.5, divide by 0.5. So we're factoring out a 0.5. We're left with an x plus, so then we have 3.5 divided by 0.5. And that's going to give us 0.5 times x plus, so this says 3.5 divided by 0.5. I'm going to move the decimal over 1, move it over 1. So now we have 5 into 35, and we get 7. Checking it, 1/2 times x is 1/2 x, or 5/10 x. 5/10 times 7 is 35. 1 number after the decimal, none, so 1 number after the decimal. Okay, we'll see you on the next video.